Okay, let's start off with mixtures. A mixture is a blend between two or more different substances. A solution is a homogeneous mixture. A homogeneous mixture has a certain pattern or uniform. You have a homogeneous and a heterogeneous mixture. A homogeneous mixture has a certain pattern or uniform, like a private school, whereas a heterogeneous mixture doesn't, like a public school. There are three homogeneous mixtures. You have a solution, a suspension, and a colloid. A suspension is when all the particles of the mixture separate over time. A colloid forms a new substance. Let me explain. The difference between a solution, colloid, and suspension is that a solution would be like salt water, a colloid would be like milk, and a suspension would be like flour in a glass of water. Now what's a solute and a solvent? Solute is a substance being dissolved, and the solvent is what's dissolving the solute. Now we have the soluble and insoluble solutions. A soluble solution can dissolve, and an insoluble solution can't. An example to tell the difference between them is that a soluble solution would be like putting salt in water and the salt would dissolve. An insoluble solution would be putting plastic in water. Now we have miscible and immiscible solutions. A miscible solution is two soluble liquids in each other. An immiscible solution is two liquids mixed together, but after time they separate. To help to tell the difference between them, an immiscible solution would be like gas and water. The gas would eventually go to the top of the water. Okay, let's talk about the solubility curve. A solubility curve looks something like this. Okay, so you have the temperature in the bottom and the solubility of the substance at the side. You have unsaturated, saturated, and supersaturated. Unsaturated means that there's less dissolved solute. Saturated solutions are just right. It's at the maximum amount of dissolved solute for the solvent. Supersaturated solutions have way more dissolved solute. It's over the limit. For this specific substance, if the temperature is at 20, the solubility rate would be at 50. This would be a saturated solution. If the temperature of the solution was 20 degrees and lower than 50, it would be unsaturated. If the solubility was higher than 50 but at 20 degrees, it would become supersaturated. There is a specific pattern throughout many of solubility curves. As the temperature rises, so does the solubility. As the solubility rises, so does the temperature. Here are 5 graphs of 5 different kinds of salts. CaSiO, NaNO3, RbCl, LiCl, and NaCl. Okay, so what's an electrolyte and a non-electrolyte? An electrolyte is an ionic compound that has an electric current. A non-electrolyte isn't, and it also doesn't have an electric current. An electrolyte would be salt and water, and a non-electrolyte would be sugar and water. Now I'm trying to get back before the cool done run out. What you see is a Tyndall effect. A Tyndall effect is a beam or scattered light caused by colloidal particles. Now comes the hard part, actually calculating concentration. 3 ways to calculate concentration: by molarity, percent by mass, and parts per million. This is the equation for molarity. the equation for percent by mass, and the equation for parts per million. What would be the concentration of a solution made with 5 grams of NaCl and 195 grams of H2O? How would you find that? By percent by mass. The grams of the solute is 5, so that's 5 divided by 5 plus the grams of the solvent, which is 195. So 5 plus 5, so 5 divided by 5 plus 195 times 100.